Dandy, guys. Today we're going to look at solving some one-step inequalities. You can see our process is going to be identical to solving the equations. We do, however, have a little bit extra to do because of the inequality. And inequality means that it's not balanced. So that's going to indicate that there's more than one possible solution. To solve an equation, again, we're going to use those inverse operations. The inverse of add 5 is subtract 5. So I'm going to subtract 5 from both sides. If you want to go ahead and draw a line down through there, that helps out. The 5 minus 5 cancels, and we see that x is greater than or equal to negative 5. Now, where we come in a little extra here, greater than or equal to, that means we have to have a number line. To make it easy, we'll just put negative 5 in the middle. Smaller than negative 5 is negative 6. Greater would be negative 4. Greater than or equal means we're going to put a dot right there. But since it's equal to, we're going to color in that dot. Greater than means shade to the right. Now, as long as you write your variable first, you're always going to point the direction of your inequality symbol. It's pointing to the right, so I'm going to shade to the right over here. We're going to show you what to do if it's not pointing to the right here in a little bit. Right down here, x minus 7 is less than negative 4. So if I add 7 to both sides, x is less than positive 3. So when I create my number line right here, I'm going to put 3 in the middle, 2 and 4 on either side. There's really no reason to have a whole bunch of numbers. After all, if you can put the number that's the key to the solution and something greater than and less than each one of those, you'll be in good shape. Since our solution is only less than, that means 3 is not included in our answer. So we're going to leave that symbol open. It's pointing to the left, so I'm going to shade to the left. Okay? Right here, 2x is less than negative 18. I'm going to divide both sides by 2, and x is less than negative 9. Yes, I have a negative answer. Yes, my number was negative, but nothing else changed how I worked it out. So for right now, we're just going to stay with what we know. Negative 9 is the key, so negative 10 and negative 8. And yes, you do have to have the numbers in the correct order as on your number line. It's only less than, so we're going to keep the symbol open. That means we can get as close to negative 9 as possible, but we can't have negative 9 as a solution, because 2 times negative 9 would be negative 18, and negative 18 is not less than negative 18. It's less than or equal to. So we do have to be careful with whether or not we have that symbol open or not. And finally, the last one right here, x divided by 9 is greater than or equal to 3. So if I multiply both sides by 9, remember, 9 is the inverse of divide, x is greater than or equal to 27. So I'll go ahead and put my number line on right here. There's 27, 28, 26. Greater than or equal to means we're going to go ahead and close that circle because 27 is included in that solution. It's pointing to the right, so we shade to the right. So what if the variable is on the right side? Because in all of these equations, the variable was on the left. What if the variable is on the right? Let's say we had something like negative 3 is less than x minus 4. Okay? Well, we would add 4 to both sides. We get 1 is less than x. 1 is less than x. That's all fine and dandy. You can work with this. But the best way to do that is to flip everything over, including the symbol. So I'm going to switch the x and the 1. Notice that the symbol is open toward the x. It's pointing to the 1. So I'm going to flip the symbol as well. So the x is pointing toward the 1. It's open toward the x. Okay? There's an easier solution right there to read. X is greater than 1. So if I have my 1 there, then I have 2, 0. X is greater than 1, so I'm going to have an open circle because it's not equal to, and greater than, since it points to the right, I'm going to shade to the right. So right here, I'm just going to say flip it all around. Flip everything around. That way you have your variable first. Always do that first. One other thing to look at. Now, this doesn't affect addition or subtraction, but let's say we have something like negative 3m is less than or equal to 21. If I'm going to solve this equation, I need to divide both sides by negative 3. Negative 3 divided by negative 3 is 1, so we have m. Over on the right side, we would have negative 7, just like we always would. Nothing has changed in our process. However, you divided by a negative. So that means you have to flip the symbol. You have to. So less than or equal to becomes greater than or equal to. Sometimes you might have to do both. You might have to flip the symbol to get because you divide by a negative, and then you might have to flip a symbol just because you're going to write the variable first again. So just kind of have to pay attention to the situation and look at it. So if we were to graph this on our number line, negative 7 is the key, so negative 8, negative 6, greater than or equal to, so we're going to fill in that circle. It's pointing to the right, so we shade to the right. The same thing would happen right here if we had something like n divided by negative 4 is greater than 7. I would need to multiply both sides by negative 4. In negative 28, here I multiplied by a negative number. Again, flip the symbol. So my greater than becomes less than. So here's my number line. Negative 28 is the key. Negative 29 on the left. Negative 27 on the right. It's less than, not equal to, so we're going to keep that symbol open. It's pointing to the left, so I'm going to go ahead and shade to the left. Make sure you get a good shade on there as well. Okay, notice it's multiplying by a negative. It's dividing by a negative. Up here, you'll notice I had a negative number and I divided it. It doesn't matter if my answer ends up negative or positive or what. What operation are we doing to both sides? If that operation involves multiplying or dividing by a negative, you have to flip the symbol. Notice I didn't talk about adding and subtracting at all. That doesn't matter, that doesn't change. The only times when you need to flip a symbol is when you multiply or divide by a negative number, or if your variable is on the right and you need to rewrite it so your variable is on the left, which makes it easier for you to graph. Okay? All right, guys, come to class with questions and we will get our assignment in class the next day. Have a good night.